Hello everybody, my name is Quinlan Walker and I will be teaching you how to download and install the Tensorflow JS library through Anaconda and onto Visual Studio Code. We will be using the Anaconda Navigator to create custom Conda environments with Node.js backend. This tutorial will cover the download and setup of the Anaconda distribution as well as Node.js, while covering all the needed steps to create and run TensorFlow programs in JavaScript. TensorFlow is the Python framework designed by Google to help developers solve machine learning problems. TensorFlow JS is Google's JavaScript framework for bringing machine learning into the browser. It can help developers build new neural networks within JavaScript or port existing ones over from Python. Undeniably, TensorFlow JS has become the best way for a web developer to get machine learning onto their website. I'm excited to show you how to get into this new frontier of machine learning, so let's get right into it, shall we? First, let's navigate to the Anaconda distribution download page. The Anaconda distribution is the internet's largest repository for data science Python frameworks. Anaconda offers easy download for over 15,000 Python data science packages. By clicking this button here, you will be able to download the Anaconda distribution installer. You might be thinking, this is a JavaScript tutorial. Why is he talking about Python? Well, let me tell you, TensorFlow is so much more than just a JavaScript framework. Using TensorFlow JS in conjunction with TensorFlow for Python allows for much faster GPU training before being deployed into the browser, giving TensorFlow powerful processing as well as large amounts of flexibility. When downloading the Anaconda distribution, be sure that the version you're downloading is the one meant for your operating system, as well as make sure that the one you have selected is the distribution with the latest version of Python. I already have Anaconda downloaded onto my computer, so I'll start by opening up the Anaconda Navigator. This will take a few minutes, so I will cut this and be right back. And we're back. As you can see here, downloading Anaconda has in fact downloaded Visual Studio Code as well. Over here is the Environment tab, where a developer can create multiple custom environments to hold different non-compatible packages. Click here to create a new environment with nothing in it, so we can have a fresh slate to start. However, first we need to install Node.js. Start by navigating to the Node.js downloads page. Once arrived at the Node.js download page, download the Node.js installer for your operating system. Once again, I already have this installed, but download the eat.exe file and run it, following the instructions on the installer. It is important for the installation of TensorFlow JS that we install the Node Packet Manager, as the Node Packet Manager helps create the directories responsible for running TensorFlow smoothly. Now click the Create button. Choose a new name for the environment you have just created. Anything you want is fine. Default settings are okay for this environment. The newly created environment will only have a few packages in it, and you will have to download any packages necessary to run TensorFlow in this environment. In order to download those packages, go and select the top left radial bar and select All, as currently only the installed packages are visible. Then go to the Search Package icon and click on it, typing in TensorFlow. In front of you is every package in the Anaconda distribution related to TensorFlow and machine learning. You're going to be installing Keras, as well as TensorFlow and TensorBoard, so you can look at your neural networks as they're being trained. A window will pop up asking you if you would like to install the packages and their dependencies. You will click Apply Changes. You could also install the GPU version of TensorFlow if you would like to use your graphics card instead of the CPU version, which only runs on your computer's CPU. This is going to take a few minutes, so we are going to sign off again, and I will be back. And we're back. Alright, we're going to come over here and open up Visual Studio Code. Now that we've got Visual Studio Code all set up, let's open a folder to create our program in. The name of the folder doesn't particularly matter, so just name it whatever you want. Select the folder and open it. Inside the folder, create a new file and name it main.js. Let's go ahead and open ourselves up a terminal. I personally use Microsoft's Azure PowerShell, but you can use whatever terminal you want. Inside the terminal, using npm install commands, download the Tensorflow JS framework. The install can take a bit of time, but be patient, it'll be worth it in the end. Here you can see the name and version of TensorFlow that was just installed, as well as the number of packages included in the install. Here we import the framework for use in our program. Note that the call for TensorFlow into our JavaScript is the same as the call for its install in the terminal. TensorFlow stores things in multi-dimensional arrays called tensors. A tensor is just a multi-dimensional array of dimension n, with n being the number of dimensions within the array itself. I am wrapping this tensor in the tf variable modifier as a way of making this tensor readable to later code. Write a console log command in order to print the tensor to the console. This will confirm that your Tensorflow JS library is in fact working. Run your program with the node command followed by whatever you chose to name your file. As you can see, our tensor is in fact working. Our install seems to have gone exceptionally well. You can see here that there's a little message saying that we may be using the wrong version of TensorFlow. I found that using the TensorFlow-node library caused a significant amount more errors, and found that it was best to use the plain TensorFlow JS for this build. You could use Bazel or some other build tool in order to make the TensorFlow JS node library work on your computer. In this message is also instructions on how to use your graphics card instead of your CPU for faster training times on your neural networks. Let's write a function f of x that returns the value of the tensors m and x multiplied together through the tf.mul function. Next, let's print the value of f to the console. Let's move on to something that's a little bit more advanced. We'll describe a loss function as something that takes in no values, but calculates the difference between f of 5 and 5 before squaring the result and returning it. Write a print function for that squared result, and run the program again. Create an optimizer object using stochastic gradient descent to help train your neural network. Set the training rate for your optimizer to 0.01%. The true magic of machine learning happens when you pass your previously defined loss function into the call for optimizer.minimize. This lets the neural network train itself to make predictions as close to the originally intended values as possible. That's why we wrapped our tensor in a variable function, so that the optimizer could get access to the values inside of the tensor and make predictions based off of those values. Use a console log command to print the neural network's predictions through the use of the loss function in the optimizer. Our console log makes use of the .datasync function due to the need to wait for a response from JavaScript for the now processed data from the optimizer. However, to get the most use out of this neural network, we need to run through this optimization function over and over again. So we're going to wrap this call for optimization into a for loop, run it 20 times, and print the result. As you can see, after several runs through the optimizer, our neural network has become fitted to its expected values and outputs predictions more in line with what you would expect from a properly trained neural network. This simple tool can be very powerful when used in conjunction with several other features of TensorFlow, which will be covered in a separate video. Thank you so much for joining me today. This has been Quinlan Walker, creating a tutorial for IMD 1005B for the winter semester of 2019 about how to download and run Google's TensorFlow machine learning framework for JavaScript. Thank you very much. Like and subscribe.